So to finish off section 1.3, we talked about the celebrities, domain and range, determining whether something was a function in class today. Tomorrow you'll need to look at something actually called function notation, which is the title of the section. So we'll take a look at that now. So the first thing you'll notice here is this f of x. F of x has the same function as y. They do pretty much the same thing. What this is telling you to do for f of x is to take whatever's in here, take x and input it into f. So if you look at this, we'll call this guy our function machine here. If you take this value x and plug it into the function, you end up with 2x plus 3. So that just defines our function. If we look at a couple more examples, you'll see how this is applied, and we can plug in some other things. For f of 1, it means we're going to go to the function f, and anytime you see an x, we're going to plug in 1. So instead of 2x plus 3, it's going to be 2 times 1 plus 3. And we end up with 5. It's not the best color there. We end up with 5, so what we can say there is f of 1 is 5. So it's just like making an xy table. When you plug 1 into this function, your output is 5. We can also plug in variables. If we take f of q, this time we're going to take q and plug it in anytime we see an x in f of x. So for f of q, instead of 2x plus 3, we're just going to write 2q plus 3. So when you input q into this function, your output is 2q plus 3. So it works for numbers, it works for variables, it's also going to work for Mr. Bevan. If we plug Mr. Bevan in for x, instead of 2x plus 3, we end up with 2 Bevan plus 3. So hopefully by now you're starting to understand the concepts. Whatever you're asked for, in this case it was g of Bevan, we just changed the name of our function, but that's fine, it can really be any letter. You plug that value in for x. So in this case we plugged in Mr. Bevan. We can also plug in an expression. So now we're being asked to plug in f of q plus 1. So if we look at f of q plus 1, instead of 2x plus 3, we're going to input 2q plus 1 plus 3. And this just has an extra step because you need to distribute here. We end up with 2q plus 2 in here. So when we plug in q plus 1 to our function, our output is 2q plus 5. So we've looked at numbers, variables, expressions. We can have any combination of those. Let's take a look at one more example. This one's a little bit trickier. This time I need to take x minus 2 and plug it in for x. So I want g of x minus 2. When I plug that in for x, that gives me x minus 2 squared plus 1. The key here is that you need to FOIL. You need to recognize that this is really x minus 2 times x minus 2 plus 1. So if we go to FOIL that, and I'll switch colors here so you can see it a little bit. When we go firsts, we're going to get x squared. Outsides is minus 2x. Insides is minus 2x. And last is plus 4. Don't forget to carry down that plus 1. What we're going to end up with for our answer here is g of x minus 2 equals, if we combine like terms here, we'll get x squared minus 4x plus 5. So that would be your final answer. Again, the key here, when there's an x squared, something like that, just make sure if you see something here where we had x minus 2 squared that you know to FOIL that. And that's it for this section. You should be able to now do the problems on your worksheet tomorrow. Just remember, whatever's in the parentheses here, whatever you're looking at, just goes in anytime you see an x into your function.